Okay, what's up? Let me fix this. Okay, we are going to make we have this ketone. We're gonna make an imine. Imine is basically just it's basically just carbon nitrogen double bond. I don't think it's nothing crazy. That's really it. So we're gonna form it. You can use a primary alcohol. I mean primary amine or ammonia. Yeah, so ammonia or primary amine. I wrote it right here. You're gonna get an amine. Honestly, I don't know what we're using. It looks like we're using a primary amine in this as an excess. So yeah, so you have a primary amine, and so we have a primary amine, and obviously we're gonna make it protonated. So this is gonna be the nucleophile. No, right now it's not a nucleophile. Right now it's just chilling. But first we need to activate the carbonyl, like in the other examples. So it's really the exact same steps as the other ones. The oxygen, the lone pair is gonna attack the hydrogen, and it's gonna go on to the nitrogen. Okay, so this is the first step, acid base. And we're gonna increase oxygen withdrawing ability, and this is wrong. We can't get, first off, we can't even get a, that's not even right. Second of all, we can't even, it's acidic conditions. We can't get a negative charge. So, uh, yep. I add an extra lone pair. Okay, we're good here. Okay, so now we're just gonna want to make a resonance structure. So yeah, just make a little resonance structure. We want to pick the minor. We're gonna get two resonance structures. Okay. Now the carbonyl is super reactive. So now our neutral nucleophile or our nucleophile, it's not reactive. So in the other examples we used oxygen. I mean we used water as a nucleophile, which is pretty neutral. Methanol or alcohol. I don't know how it looks pretty neutral or like chill. You could think of like alcohol as chill as a chill nucleophile. And in this example, the amine, it's also pretty. It's honestly pretty chill as well. So they're all chill, but the point is like it's gonna attack this. Like once we have the charge on the carbon, it's really reactive. So now it's gonna attack it. So now just use whatever is in excess, which we wrote on the bottom, what I have on the bottom. So it's gonna attack right here. So um, yep, just form this. We're gonna form protonated amine. I don't know the nomenclature. Just we're gonna form an extra bond, a charge on it, on the nitrogen. Okay, so okay, good. Now we have a charge on it. Charge isn't good, so whatever's in excess is gonna deprotonate it. So our amine, a primary amine or just amine is gonna deprotonate it. And now it's gonna go on the nitrogen. I should be more clear with that. And so now we're almost done. I mean, we're really almost done. So our our answer. I don't know. I'm talking about answer. We're not done yet. Need to chill. Um. So what is an amine? Or we need to form an amine. I'm not. I'm not even looking at any answers. I just need to think this through. An amine is a carbon. Is a night. Yeah. So it's obviously a CN. So obviously the OH needs to get the hell out. So how is it gonna leave? It can't leave on its own. First off, if it leaves on its own, it really can't. OH never leaves on its own. It's not a good leaving group. So we're gonna have to make it a good leaving group. We just formed this protonated amine thing. So obviously, so we just formed this. So now it's gonna have more desire to leave if we put a positive charge on it. So now it's gonna leave on its own. But just remember, you cannot get a prime, you can't get a negative charge. So make sure when you're doing the mechanism, make sure you never see a negative charge. Like that means you did something wrong. So I think there is an extra H right here, so that's why he's leaving. So yeah, so he's gonna leave. The water is gonna leave. We're gonna leave. Water is gonna leave. So um yeah, so I don't know what to do now, honestly. This doesn't look right. There has to be an H on it. Yeah, right here there's an H. Right here there's an H. Yeah. Okay. Now what do we do? I mean, um, maybe I did something wrong. I just remember OH leaving. That makes sense, right? The OH has to leave. So now like Maybe if I draw it like in a different way, I might figure it out. Like, what if we have that, and then yeah, I mean, so how do we get this to be? Oh, yeah, okay. If it leaves, then there is a charge right here, and so good, good, good. If it leaves, we're gonna have a charge right there, and so if we have a charge right there, then the NH is gonna attack again. Okay, bet. I figured it out. Um, how did it look? It looked like that, and then make it proper. Yeah. Okay. I'm sorry. Yeah, it's gonna attack right there, and there's no way it attacks twice, bro. That's crazy. I feel like you could just put like a double bond on it. Yeah, I feel like that's not right. I feel like if we put a double bond on it, because we're not trying to make two. Why would we make two? That doesn't make any sense. So I feel like if we push electrons right here, then we can get our answer. That makes more sense, right? It could be protonated. Like this is gonna have a lot, right? And so now our thing in excess can deprotonate it, and we could form our acid catalyst. Yeah, this is definitely right. I'm just figuring it out right now. See, this is like trial and error. Yep, right here, and then now we should get our answer. I just fixed. This is the resonance structure, and now we're gonna get our answer, which is the imine plus our catalyst. Yep, that's the answer. Yeah, if you just want to, so I'm gonna just go over this quickly. So I'm gonna just like explain the difference between imine and an enamine. I don't know what an enamine is. You can search it up, but I'm gonna tell you like what forms in what situation. 5. Whoa, how many steps did I write? Did I skip a step? Because I'm supposed to get 6 steps. 1, 2, 3, 4, 5. Dude, what the hell happened? Man, F it, bro. Um, maybe I just didn't write it right. Maybe maybe right here is step 4. Maybe this is step 4. Maybe I just didn't write the freaking arrows. Yeah, this is step 4. I'm bugging. See, I would have lost points for some shit like that. Right here. Okay, we're good. We're good. This is step 5, and this is step 6. Okay, so my notes, right? Okay, this is a ammonia, and this is a primary amine. Primary amine just has an R group. This is gonna form an imine. This is gonna form an enamine. As I said, an imine is CN. An enamine, low-key, I should have prepared what an enamine is. Like, you can search that up. I just don't think it's just not CN. There's like a space between it. I think it's like a little bit different. Whatever. Point is, ammonia and a primary amine, we're gonna get we're gonna get an imine. Okay, so look, in step, I put it in the notes right here. Step 3, we're gonna have the first nitrogen proton loss. So where to go? Step 3, we lost our first hydrogen. Great. Okay, and so step 6, we're gonna have to lose another hydrogen to become the imine. This is what happened. Oh, why did my arrows go there? Yeah, this is step 6. I'm bugging. This is step 6. I was looking at this. No, no, no. Chill, chill, chill. I should be more. I should definitely like work on like being more like. Who the hell cares, bro? This is step 6. The H is leaving. It's being taken away from the nitrogen. So that's why an imine forms. An enamine. Why doesn't it form from a secondary amine? Listen, a secondary amine only has one H. So, in when we're talking about imine, we lost an H in step 3 and step 6. But because we had two hydrogens. But an imine, a secondary amine only has one hydrogen. So how is it gonna lose the second hydrogen in step 6 to become the imine? It is not gonna happen. That's why this is the reason why primary amine. Just remember this. No, NH3 and the primary amine becomes imine. Secondary amine can't become an imine because it only has one hydrogen. If you remember that, you should be good. I'm just go over like little things. We replaced our O with N. So if you want to like predict the product really quickly, you see this right here. Just just move this and replace it with this. That's it. You should be good. And I think that's all you need to predict the product. How do I end the video?